Ever wonder what it takes to outpace an entire country in rocket launches? Elon Musk's SpaceX did just that, leaving Russia trailing behind in the wake of 2017's rocketry revolution. But here's the twist. While making headlines with its launches, SpaceX managed to do something unexpected. Picture this: a rocket tearing a hole through the very fabric of our planet's atmosphere, a rupture almost 560 miles wide. Now you might be wondering, how is this possible? And what does it signify for the future of our cosmic ambitions? Let's find out. The Falcon 9 rocket holds the distinction of being the initial privately created liquid fuel rocket to achieve orbit. It has played a vital role in launching, orbiting, and recovering spacecraft. Additionally, the Falcon 9 has been employed in transporting astronauts to the International Space Station. And on Monday, August 7th, the Falcon 9 successfully took off from California's Vandenberg Space Force Base. Its mission was to place 15 Starlink satellites into orbit. It's worth mentioning that SpaceX holds the Falcon 9 in high regard, proudly asserting it as the world's inaugural reusable rocket capable of reaching orbit. This remarkable rocket has an impressive history, boasting 240 launches and an impressive 198 successful landings. In the year 2022, the Falcon 9 rocket achieved an impressive milestone, completing a record-setting 60 launches, all of which were successful within a single calendar year. This remarkable feat surpassed the previous achievement held by the Soyuz U rocket, which accomplished 47 launches, with 45 being successful, in the year 1979. The Falcon 9's journey began with Falcon 9 Volts 1.0, launching 5 times from June 2010 to March 2013. Falcon 9 Volts 1.1 followed, with 15 launches between September 2013 and January 2016. The evolution continued with Falcon 9 Full Thrust, achieving a staggering 226 launches from December 2015 to the present. Notably, the Block 5 variant, introduced in May 2018, is designed for up to 10 flights with minimal maintenance, a significant improvement over Block 4's 2-flight limit. The Falcon Heavy, derived from Falcon 9, features a strengthened core stage flanked by 2 Falcon 9 boosters with aerodynamic nose cones, differing from the standard inner stage. Falcon 9's first-stage boosters showcased remarkable landing precision, with a 95.2% success rate out of 229 attempts. The Block 5 version improved this to 97.4% out of 193 attempts, accomplishing 194 successful reflights. Instead of directly challenging gravity to ascend vertically, rockets typically follow a curved path, skimming close to the planet's surface at approximately 80 to 100 kilometers above Earth. This approach enables spacecraft to transport more sizable and weighty payloads into orbit, surpassing the limits of a straight-up journey. But during the Formosat 5 mission in August 2017, SpaceX employed the Falcon 9 rocket to transport a relatively lightweight Earth observation satellite for Taiwan's National Space Organization. This satellite weighed only 475 kilograms, which was considered a modest load for the Falcon 9. But during its flight, an intriguing phenomenon occurred. The rocket's exhaust, primarily composed of water vapor and carbon dioxide, interacted with the Earth's ionosphere. As a result of this occurrence, an extraordinary spectacle unfolded in the sky, resembling a crimson aurora-like illumination. The dramatic display captured the attention of onlookers and scientists alike. As the satellite was quite lightweight, the rocket followed a nearly vertical route into space. This led to the Falcon 9 booster and second stage producing circular shockwaves, resulting in a substantial gap being formed through the ionosphere's plasma. This hole, spanning 559 miles, persisted for as long as 3 hours. As explained by space physicist Jeff Baumgartner, it's not unusual for rockets to create temporary disruptions in the ionosphere, especially when their engines burn at altitudes around 200 to 300 kilometers above the Earth's surface. The recent happening with SpaceX's Falcon 9 is a case in point. When the Falcon 9 launched, its second stage engine burned at roughly 286 kilometers, near the highest part of the ionosphere known as the F region peak. This strongly suggests the likelihood of an ionospheric hole being generated. So what is the ionosphere? The ionosphere is a layer in our planet's upper atmosphere, situated between 75 kilometers and 1,000 kilometers, approximately 46 to 621 miles, above the Earth's surface. In this region, atoms are ionized by the sun's energy and cosmic radiation. Solar and cosmic rays remove one or more electrons from atoms, resulting in a positive charge and leaving behind free electrons. This layer is where auroras take place. It shares space with the mesosphere, thermosphere, and exosphere. The presence of ions and free electrons enables the ionosphere to reflect radio waves. This reflection serves to facilitate communication over long distances on Earth, as well as between satellites and our planet. During daylight hours, energy from the sun in the form of X-rays and UV light continually dislodges electrons from atoms, leading to the creation of ions and free electrons. These individual particles interact, collide, and then recombine, ultimately returning to their electrically neutral state as atoms. When night falls and the sun's energy diminish, more particles combine than are ionized, causing the ionosphere to contract. Although cosmic radiation still influences this part of the atmosphere, only the atoms in the upper portion remain ionized. These ions emit red or green light during auroras when they interact with the solar wind and radiation from events like coronal mass ejections or solar flares. But this interplay caused the Californian sky to exhibit a red hue. This atmospheric layer plays a vital role in radio communication, as it reflects and bends radio signals. Consequently, the formation of these ionospheric holes can disrupt such communications. These occurrences used to be uncommon, but they've become more frequent due to the rising number of rocket launches. This trend is evident from a recent event where another Falcon 9 launch produced a similar effect just a few weeks ago. According to Charles Lin, an Earth Sciences professor at Taiwan's National Chung Kung University, the world is now witnessing a period where rocket launches are becoming frequent. This shift is attributed to the cost reduction brought about by the utilization of reusable rockets. Meanwhile, humans are developing more powerful rockets to send cargo to other planets. These two factors will gradually affect the middle and upper atmosphere more, and that is worthwhile to pay some attention to. While the hole created by the SpaceX launch was a short-lived event, the increased frequency of commercial rocket launches carrying satellites into orbit could lead to more frequent disturbances in the ionosphere. Notably, private space enterprises secured an impressive $3.9 billion in private investments in 2017 alone. Looking ahead, projections suggest that by 2040, the industry could be valued at an astonishing $3 trillion. One potential outcome of this rapid industry growth and the increasing number of rockets entering the atmosphere is the potential for errors in the Global Positioning System, GPS navigation, warn scientists. When the Falcon 9's second-stage rocket burned through the ionospheric plasma and created the hole approximately 13 minutes after launch, it likely introduced a GPS error of around 1 meter. Charles C.H. Lin, the main author of the study and affiliated with Taiwan's National Chung Kung University, likens a rocket launch to a miniature volcano eruption. This comparison highlights how energy is released into the middle and upper atmosphere, akin to the effects of a magnetic storm. Lin explained to Ars Technica that even without considering the effects of rocket launches, errors from the ionosphere, troposphere, and other factors can result in discrepancies of up to 20 meters or even more. But according to reports, experts are planning to look closely at the disruption in the ionosphere. They want to understand more about what happened and what it means. SpaceX's dedication to new and creative space travel, along with the information learned from events like this, helps us learn more about space and technology. Baumgartner looked at videos from another launch on July 19th. They showed the second stage of the rocket burning at about 286 kilometers, which is close to the highest part of the ionosphere called the F region. This makes it likely that the rocket created a gap in the ionosphere. Interestingly, this isn't the first instance of such an occurrence involving the Falcon 9 rocket. A previous launch from the Vandenberg Space Force Base on August 24, 2017, carrying the Formosat 5 payload, produced shockwaves due to its vertical path, resulting in the formation of an ionospheric hole within the plasma. Likewise, a similar incident occurred during Falcon 9's launch on June 19, 2022, as reported by Science Times. These observations underscore the importance of comprehending and studying the effects of rocket launches on the Earth's ionosphere. These effects can influence communication and navigation systems that rely on ionospheric conditions. Additionally, these events offer valuable insights to researchers in the world of space science and exploration, further enhancing our understanding of the Earth's upper atmosphere. What are your thoughts on this? Let us know in the comments. With that said, thank you for watching. Don't forget to hit that subscribe button and stay tuned for more.